This video is about real number system and order of operations. So the real number system is how we group numbers. We have different categories of how we can group numbers together. So first what we started with was called the natural numbers. So that's just counting from 1 on up. It's like you're counting normally, 1, 2, 3, 4, 5, 6, what you learned as a kid. That's why they're called natural, because they're natural to us. Whole numbers are almost like the natural numbers, except they include 0. Same thing, it just keeps counting up. Integers, again, are similar to the first two. They include everything the first two do, but they include negative numbers as well. So we could count in both directions. Rational numbers are all of the stuff up above, integers, whole numbers, and natural. So they include integers, whole numbers, and rational. But they also include fractions, whole numbers, rational. Let me finish that list. They also include fractions, decimals that stop, and decimals that repeat. So for example, fraction, 1/2, decimals that stop, 0.8, and decimals that repeat would be something like 0.33333333. It's the same number over and over again, or I could have 0.151515. It can repeat at any point. It doesn't have to be just the same exact number. So the last one is called irrational. And that is a decimal that doesn't repeat. 0.1274138. Just there's no pattern to it at all. It's just random numbers. So the way we get an irrational number is by using square roots. But they can be tricky. If I said square root of 27, that's definitely irrational, because when you go plug it into a calculator, it gives you 5.196152423, nothing repeated, it's just a random set of numbers. But if I were to do square root of 25, we would think, hey, that's the square root symbol, this is irrational. But when I go plug in square root of 25 into a calculator, it comes out as 5. 25 is called a perfect square because when you square root it, you get an integer or a whole number or a natural number. It fits in all those categories. You get that number when you square root. So you do have to be careful about square roots. Also, pi is considered irrational. The symbol pi actually represents the number 3.14159, and then again it keeps going forever with no pattern. So with our number system, you can kind of put it together in a diagram that helps you identify what categories the numbers will fit in. So first we had natural numbers. Sorry, I had to split it because I didn't have enough room to write it. Then we have whole numbers. Then we have integers. I'm going to make this a little bit smaller because it's not going to fit on my screen if I keep going. Then we have rational numbers. Irrational numbers are in their own little category. And then all together, all of these numbers make up what's called the real number system. So the reason we group it like this is because if I give you a number to identify and I say, what categories can this fit in? If I want you to name all the categories this would fit in. So let's say -1. We want to find the smallest circle that -1 would fit in. So looking at natural, -1 doesn't fit in natural because those are all the positive counting numbers. Whole, -1 doesn't fit in whole numbers because that only was 0 and all the positives. Integers, -1 does fit in integers. So we are in this circle, but that means we're also in some other circles. Rational numbers still make a circle around integers, so -1 is an integer. It's a rational number. And then the biggest circle of all, real numbers, it's also a real number. Let me get rid of some of this so we can try a different number. Let's say we have 2.357. Okay, so that's a decimal. There is no pattern, but the decimal stops. I didn't put the little dots after to say, hey, this keeps going. So that means we have a rational. That's the smallest circle it can fit in, is rational. So we fit in rational, and rational also fit in real, so we're considered also to be a real number. Irrational is kind of its own little circle. So if I were to give you a different example, like square root of 10, now I double check and make sure that this is not a perfect square. So square root of 10, when I plug it into a calculator, is 3.16227766. So kind of looks like there's sort of a pattern where we have these groupings of 2, but it has to be something we can definitely see is repeating. It'd have to be 2277, 2277. So since it ended with 66, we know there's no pattern. So this is irrational. So we fit in irrational. That means we don't fit in any of these other circles, but we do fit in the real number circle still. So we can fit into multiple categories at the same time. One last example, if I were to just give you the number 3. 3 is a natural number. That's the smallest circle it can fit in, which means it's also a whole number. It's also an integer. It's also a rational because all of those fit natural numbers inside of it, and it's also a real number, so it fits in a lot of categories. So our second topic is order of operations. Order of operations are talking about the order you should do math problems in when you're simplifying an expression. So, order of operations, we usually use this way to remember called PEMDAS, or you'll often see it represented as please excuse my dear Aunt Sally. This is telling me first I do anything inside of parentheses. I think that should actually be an E there. Then the E means do anything that has an exponent next. M and D stand for multiply and divide, and they're actually grouped together. M and D means we're going to do multiply and divide from left to right. If there's a whole long list of multiplication and division, we go from left to right. And then the last one, add and subtract. Same thing as multiply and divide. We do all our adding and subtracting together from left to right. So let's look at an example. So when we read, we're used to things going from left to right reading, but that is not the case with order of operations. We have to follow this order, PEMDAS. So P stood for parentheses. And when we say parentheses, that means we're going to focus on anything inside the parentheses. When we focus inside the parentheses, we've actually got to start order of operations again. It's possible that maybe we have a second set of parentheses inside. In this case, we don't, so we move on to exponents, E. There is an exponent inside the squared, so we have to do that first. So just the parentheses, 5 squared is 5 times 5, which is 25. Then we look for multiply and divide. There is no multiply and divide inside the parentheses. Again, we're just focusing inside the parentheses right now. So we skip multiply and divide and move to add and subtract. 3 minus 25 is negative 22. Now everything else that we've been kind of ignoring isn't gone. We still have them as part of the problem. So now we've got to start back at the top. Parentheses. Well, yes, there are parentheses, but there's only one number inside now. There's nothing to do inside the parentheses. So now, these parentheses are actually considered multiplication. 2 times negative 22. So we said parentheses we can skip. We look for exponents. There are no exponents in the entire problem. So we skip to multiply and divide. We have multiply, 2 times negative 22 is negative 44. Bring down everything else. Then we look at add and subtract. Now there is addition and subtraction in this problem, but we just start at the left side of the problem and go to the right at this point. Since there is only addition and subtraction left, we start at the left and go to the right. Negative 44 plus 7 is negative 37. We still bring down the minus 10. Negative 37 minus 10 is negative 47. And that would be our final answer. So let's look at one that can be a little more complicated. Okay. So again, we have to follow our order of operations. First, we would start with parentheses. So we're going to look for any parentheses. These brackets here are considered parentheses. Looking inside, we start over again and say, okay, look for parentheses inside the parentheses. And this time we do have a second set of parentheses. Now we look at those parentheses. So right now we're working just with the red underlined stuff. Inside those parentheses, we don't have another set of parentheses, so we can skip that. We go to exponents. We do have an exponent, so we have 3 squared is 9. We've done our exponent. 3 squared again is 3 times 3, which is how I got the 9. Squared means multiply that number by itself. Then we look at multiply and divide. There is no multiplication and division inside those parentheses, so we can skip that. Then we move on to add and subtract. 9 minus 5 is 4, plus 13 is 17. So now I bring down everything else. Everything else is still part of this problem. And we start our order of operations again. So we already know there are some parentheses. Again, I do not consider this 17 in parentheses under the parenthesis category anymore because we've simplified everything inside down to one number. Now it's considered multiplication. So we're looking at our parentheses, this time our parentheses in blue. There are no exponents inside the parentheses. We do have some multiplication and division. Again, we have to go, since we have divide, then multiply, we have to go from left to right. I know it says MD, so we want to do multiplication first, then division. That's not the case. That's just saying we need to do multiplication and division at the same time. So from left to right, 2 divided by 2 is 1. So we did those two. And then 1 times 17 is 17. And again, now we bring down everything else. 3 plus 5 squared. We have that 17 there already, minus 8. Now, we start our order of operations again. Order of operations we really have to do a couple of times within these more complicated problems. Parentheses we can skip because even though the brackets are, yes, parentheses, since there's only one number inside, it's now changed to being considered times only. Exponent. We do have an exponent. 5 squared would mean 5 times 5, which is 25. Taking care of our exponents, we look for any multiplication and division. 25 times 17 is 425. Still bring down everything else. Now we look for addition and subtraction, and we just go left to right. 3 plus 425 is 428. 428 minus 8 is 420. So that ends our discussion on the real number system and order of operations.